the last video, number 126, is still about quadratic number patterns. The sum I gave you to try was the consolidation exercise on page 48. The one I said to you to try, please, is number G that says, a quadratic number pattern has a constant second difference of 6. Clear? Then the fifth term is 80. And the 10th term is 315. Find the number pattern. Find the general term. Different. Very different. What have we got, right? What do you know? So you know that the second difference, I don't even know how to write that, but all I know is it's going to get to second difference of 6, right? So I don't know what's happening to the top, but then my original one was 1, 2, 3, 4. The fifth one was 80. Then there was the 10th one, 6, 7, 8, 9. 10th one was 315. That's the total of my information. Find TE. Ideas. What's the only physical thing you know? Second difference, how does that help me? Aha! So 2A is 6. I don't have that, but I at least know that A is definitely worth a mark out of the 5 or 6 marks that this is going to be. So then, if I have A, how does that help me my general term? What was the general term? Right? A squared plus BN plus C. Right? At least I've got a mark. Because I know that the second difference is equal to 2A, and that A is going to be 3 in the general term. So I still have to go find B and C. But what's the other information I have? Because there's nothing else to do with the 6. What's the other information that we have? So what is 80? Term number 5. How am I going to use it? Term number 5 will mean I substitute every n with a 5. But then I've got an expression with 2 variables, but it's more than that. It's not an expression, it's actually an equation. Where's the 80 coming from? Term 5 is 80. So there's a relationship between them in the B and the C. Let's simplify that a little bit and say this is going to be 75, am I right? Plus 5B plus C is equal to 80. Okay, I'm a little bit stuck. I can at least add the 75 and the 80 now or later, it doesn't matter, but I've got 2 variables. So in the back of your mind you're thinking, the way to do that is 2 variables, simultaneous equations, but then I need another equation.
You do.
And I've got another one. Because that one will mean that T, let me write it here, term 10 is going to be 3 times 10. B times 10. And the answer is 3, 1, 5. So I know that is equation 1. It can be simplified, I know. This one is going to be my equation number 2. When I time it's going to be 300 plus 10B plus C, and we definitely see that we do have simultaneous equations. Now it's up to you what you want to go do with it. Because we could even do elimination. So remember elimination from grade 10.
Yes.
If you put these underneath each other, there's numbers, there's B's, there's C's, equal, another number. I'll write it a little bit better, but you can do elimination. What are you going to eliminate?
C's.
The C. When you subtract them from each other, there's going to be no more C. The one that we generally, normally, mostly work with is substitution. So let's say, I don't look at the first one. If we have C equal to, make it the top subject, we're going to have C is equal to 80 minus 75 is going to be 5, right? And then minus 5B. That's better for 1. Still 1. And then the other one, If I also want to do that, and you don't have to, you can now go and substitute that right in here with everything else as well. But you can also go and say C is equal to,
15.
it's going to be 15 when you take the numbers across, and then minus 10b. Now it's even easier to see the elimination process. If you wanted to eliminate, you'd say subtract the top minus the bottom. That'll be 0. That'll be minus 10. And that'll be plus 5. B. Solve for B. And B is equal to 2. That's elimination. When I say 1 minus 2. That's the one that you're not so used to. Because you can only use it in certain circumstances, but you can generally, normally always use substitution. Well, I'm going to substitute the 1 into the other one, which is going to mean, if I do that, 5 minus 5b is going to be equal to 15 minus 10b. Make sense? Because the c's are the same, so that's actually the same. When we solve it, it's going to be 5b if I take the b's to the left and 10 to the right. It's coming down to the same thing because b is still going to be 2. Different techniques, methods can differ. So I've got my b, yes. I'm still looking for my c. What do we always then do? We go back to whichever one you want to go back to. This one, it'll be c is equal to 5 minus 5b, which was 2. So that answer is, guys, you're sleeping. So that my general term is going to be 3n squared, which I got right from the start, that mark. But then the b part is going to be 2n and the c part is going to be negative 5. And I didn't use our little recipe of 2a, 3a plus b, a plus b plus c. But the crucial part was the 2a. If you didn't use that, you didn't have your a. And you don't know how to do 3 different equations with 3 different variables. There is such a technique, it's not your syllabus. You know 2 variables with 2 equations. Done. Are you with me? Can you see why we had to go do that? Just to make sure that you're on top of it? Okay. That is the end of grade 11 maths. Good luck.